Hello everyone, in today's video I'm going to solve certain questions based on the concept discussed in my previous video. So here is a question from csir net. If f is a function from x to x such that f of x is equals to x, then we have to tick on the correct option. Now f of x is equals to x, which implies f of x is equals to f inverse x. So this is the property of self inverse of a function. This means that f is the inverse of itself, and according to the definition of inverse of a function, f is 1 1 and onto. How? See, because let f be a function from x to y, then the inverse of f exists if each element small y of capital Y corresponds to not more than 1x of capital X. If this is x and this is y and this is a function from x to y, then it's given that it means its inverse would exist if each element of y, if each element small y of capital Y corresponds to not more than 1 small x of this capital X, then a function with this property is called what? Injective function, that is 1 1, so therefore it's 1 1. All right. And if f inverse is a function on y, then each element y must correspond to some x. That means each element of this codomain is mapped to some element. Fine. That means this is the definition of onto function. So therefore it's also onto. So here the answer is f is both 1 1 and onto. This one. Here is the second question. Let m be less than equals to n be natural numbers, then the number of injective maps from a set of cardinality m to a set of cardinality n is. Now if you remember the formula discussed in the previous video, then there it was written that the number of 1 1 functions is equals to npm if m is less than equals to n. Alright, where m is the cardinality of A and n is the cardinality of B. Fine. So here it's given that the number of injective map from a set of cardinality m to the set of cardinality n means, suppose f is a function from set A to set B, then the cardinality of A is given as m and that of B is given by n, and it's given that m is less than equals to n. So we can apply this formula. Fine, because this would be 0 if m is greater than n. Okay, so here we can apply the formula, and according to which the number of 1 1 function is npm, which is equals to n factorial by n minus m factorial. But in this here we can't find this answer, so the correct answer over here is none of this.